So the PIAL International Paper, new specification, January 2023, question 7 here. We've got curve C, we've got x in terms of y and trigonometric function as well. And we've got to show, it's kind of standard theme, we've got to get dy by dx when x is in terms of y, and this is in terms of x. And then it talks about tangent, and then that's the x-axis. So here we go. So if we're differentiating this in terms of y, so we get dx over dy, we're going to have 3 and then sec squared y minus pi over 6. We've got to get this in terms of x though, because dy by dx is in terms of x here. So I'm going to get this in terms of x by using a trig identity. We know that sine squared plus cos squared is equal to 1. If we divide it all by cos squared, we get sine squared over cos squared over cos squared, 1 over cos squared, which gives us that tan squared plus 1 is equal to sec squared. So I can write this sec squared as tan squared plus 1. So this is 3 lots of tan squared of that y minus pi over 6 plus 1. Like I say, I want it in terms of x. So if I rearrange this, the tan y minus pi over 6 is x over 3. So this is x over 3 all squared. If I do things with that bracket, put the 3 in the bracket, I'll have x squared over 9 multiplied by 3, just x squared over 3. I'll have a 3 there. I'm going to want to flip it. So if I write it as one fraction, I've got x squared plus 9 over 3, because that 3 is 3 over 9. And then to get the dy by dx, then I'll just flip this fraction. So it's going to be 3 over x squared plus 9. And then it's in that form then, where the a is 3 and the b is 9. Then it says the point P has got the y coordinate pi over 3. Given the tangent across the x-axis of the point Q, we've got the dy by dx from the first part, sort of in terms of x. So if y is equal to pi over 3, I want the x really, and the x is 3 tan y minus pi over 6. Pi over 3 minus pi over 6 is pi over 6. Tan pi over 6 is 1 over root 3, multiplied by 3, just gives you root 3. So that's the x value at the point P. So the dy by dx, which I need for the gradient of the tangent. So the dy by dx, just sticking this in here, 3 over the x squared plus 9. That's 3 over 12, which is a quarter. I can get the equation of the line then, the equation of the tangent, by doing y minus the y value and the m, the gradient, times x minus the x value. I'm not going to do any simplifying straight away though, because I just want the x coordinate of Q where it hits the x-axis, where this line hits the x-axis. So I'm just going to sub in y is equal to 0 into here. 0 minus pi over 3 is a quarter. So you can see I've just got minus pi over 3 is equal to a quarter times that bracket. Multiplying by 4 to get rid of the quarter, because I just want to say x equals. So I'll have minus 4 pi over 3, and then I need to add this root 3. So that is the final answer, x is root 3 minus 4 pi over 3.